Hi, astronomy class. Happy Thursday, last day for school this week. We got no school tomorrow, so like it's not even an official e-learning day. It's like you're supposed to be like doing no school at all. So that's what it's going to be. No school for us tomorrow, and then we've only got 2 weeks left, and we're done. So, uh, with that being said, we don't have much time. So we're going to jump right into today's lesson. Yesterday, you worked on this worksheet here, and I made a graph with you here. This is what my graph looked like. Yours probably looks something like that. My little data points aren't very neat, but that's okay. They're in the right spot, just about. So, what this graph is, we started talking yesterday about how we can measure the speed of galaxies. So, some galaxies, actually, all but one galaxy, appear to be moving away from us. They're all redshifted. So, when you look at their light spectrum, the light gets shifted from its ordinary colors towards the red end of the rainbow. And that tells us that they're all moving away from us. And I asked the question, well, is there any kind of pattern to this redshift? Like, can we see if there's a relationship between the distance to that galaxy and how fast it's moving away? And that's what we looked at yesterday. I gave you a data table of a bunch of different galaxies and their distances, and then also their spectra. And I asked you to figure out, based on their spectra, how fast they were moving. And then you should have done that and then plotted your data here. And you can see a pretty clear relationship. The further away that the galaxy is, that as the distance goes up, its speed goes up, and it's a pretty consistent relationship. Now, it's not a perfect mathematical relationship here, but there is a general trend, and so I'm going to draw a line to kind of show the general trend here. Oh, that's not a good line. Let me try one more time. That's better. That's still not great. I'm picky about these kind of things. All right, so this shows basically the general trend of the data points, and it basically demonstrates there's a relationship there. As you increase the distance, the speed will also increase. Okay, so that's what this number three question is asking you here. It says describe the relationship between the distance to the galaxy and the speed it is moving away. You could say a bunch of things, but basically, the further away the galaxy is, the faster it appears to be moving. All right, and then I had some other practice questions here. So based on like the line that I drew here, what do you think? What distance should a galaxy be away if it had a speed of 1200? So looking at my line, 1200 speed is right here. That should be about 4.5 times 10 to the 20 kilometers away. And then for number five, if it was moving at 5,600 kilometers per second, what distance should it be? So 5,600, that's way up here. See what that's at. Okay, that's like over 25, probably 26, 27. So you're going to have numbers that are a little bit different than mine based on how you drew a line here, but but that's okay. It just, I'm not looking for complete accuracy. There's not supposed to be an accurate answer, but you're just supposed to see that there's a relationship here, that the further away a galaxy is, the faster it's going. So coming back to our presentation, um, all the galaxies are redshifted, and we now have found a pattern in the redshifts, and the distance to the galaxy is related to the amount of redshift. So let's look at two conclusions and two observations, I guess we could call them. So, observation number one about the galaxies and the universe at large, all the galaxies are redshifted. And I'm saying all because I'm not including the one galaxy that is actually blue shifted moving to us, the Andromeda galaxy. I'm going to ignore that one and just consider the rest of the galaxies. So, what does this observation imply about the motion of galaxies relative to us? I just said that all but one are moving away. And we already did that. So, observation number two, the farther galaxies move faster. Okay, so the farther away the galaxy is from us, the faster it is moving away. Interesting. Okay, this is not what you might expect to see. When you look out at galaxies, you wouldn't expect to say that they're all moving away and then also that the ones that are farther are moving faster. How does it know to move faster if it's farther away? What does this mean? This is what we see. This is the observation that we make. So on Earth, we have this is I think this is the sodium spectrum lines. But when we look at galaxies, we see these lines shifted, and the further away the galaxy is, the more the shift. So I want to compare this to some donuts. Now, back in Bowling Green, where I taught when we were first taught, we had a Krispy Kreme that just opened up, and it was the talk of the town. And the greatest thing about Krispy Kreme, if you don't know, well, it's not the greatest thing, but one of the fun things about Krispy Kreme is that you can watch their donuts on a conveyor belt. Do you know this? Have you been to a Krispy Kreme that does this? So they usually have like a little window where you can like peer in and you can see the wonderful sweet donuts rolling down the conveyor belt, and it just makes me want some Krispy Kreme. But yeah, you can watch them on a conveyor belt. That's my point. And I think about donuts when I think about the universe because of a connection that my wife helped me make. She came up with this analogy that I want to share with you. It's all about things that move away. So I want you to think about what it looks like when two donuts are on a conveyor belt and you are in one of the most sad positions in the world. They're moving away from you. So here's donut one and donut two on a conveyor belt, and it happens to be moving away. Now I worked really hard on this animation, so please just take it all in here. Here we go. So the donuts are moving away from you. Okay, so if I asked you a question about the speed of these donuts, how would you describe how the speed of donut one compares to the speed of donut two? Right? Take a minute to answer that question. Describe the speeds of the two donuts. Okay, hopefully you could tell me that donuts one and two are moving away from you at the same speed, right? Because they're both on a conveyor belt, so they're being carried along this conveyor belt at the same speed, and so they're moving away from you at the same speed. The farther one moves away at the same speed as the closer one. Okay, well, let's do something different in this bottom example. What would happen if you, instead of letting the conveyor belt roll and turn, and move the donuts that way. What if you kept the donuts on the conveyor belt and turned the conveyor belt off, but then you decided to stretch out the conveyor belt? Let's say it was made of like rubber or something, and you stretched the conveyor belt. You kept the end of the conveyor belt close to you, fixed, and then you stretched this end of it. How would that change how the donuts moved away? So I want you to watch. This one is really important to watch. Okay, so watch closely at the bottom conveyor belt as I stretch it out. Okay, do you notice something? Um, One, it's a very pixelated image and it's low quality animation here. But two, you should notice that both donuts moved away from you. Which one moved away faster? If you look closely, donut two must be moving faster than donut one. In order for it to be all the way over here, donut two had to be moving faster than donut one. They both started out next to you. Let's do it one more time. Okay, so as I stretch out the conveyor belt, donut 2 is moving faster than donut 1. Okay, and that's because the conveyor belt beneath it is stretching out. And the more conveyor belt there is between you and the donut, the more stretching there will be. Let me say that again. The more conveyor belt between you and the donut, the more amount of stuff that's going to get stretched out. So it's going to move away faster. The closer donut doesn't move as much because there's not as much conveyor belt that's stretching. So, what does this mean about the motion of galaxies in the universe? Make a prediction. Connect this to what we just witnessed in our data. So, what does this mean about the motion of galaxies in the universe? If donuts resemble galaxies, then it must mean that galaxies aren't actually moving, but the space between them is expanding. Make the connection here. If it's true that the farther the galaxy is away from us, the faster it's going, it's more accurate to talk about it's not that galaxies are flying through space, but instead it's more like the galaxies are fixed in place and that something or someone is stretching the space between them. So if you take two donuts, I mean galaxies, and you watch them, the farther one will move away even faster than the smaller one. That must mean that the space is expanding between them. Space is expanding. This is something that we've discovered when we look at the data from the galaxies that we've seen. And this is stuff that we understand. Like, we know what redshift is, we know how to measure the speed of galaxies, and we know how to measure their distance, right? We can use standard candles, type 1a supernovae, to measure distance. We measure speed. We see a simple relationship: expanding space. Space is expanding, and that tells us something incredible about our universe, that it's active and it's moving, and things are happening in it. Space is expanding. So this is what Hubble's law is all about. That when you look at galaxies and you watch them closely, you see them. The further ones are moving away faster. That's what this is trying to illustrate here. Let's say that we are in this star or this galaxy, and we're looking at our nearby galaxies. Well, if we measure the distance to these galaxies today and then measure it again later, we'll see that the two galaxies that are kind of closer aren't moving as quickly as the one that's farther away. The farther galaxy is moving faster. This only makes sense if you consider that space is expanding. It's kind of like a balloon. You take a balloon, you dot the balloon in different places, and you blow it up. Well, the closer dots move away a little bit from each other, but two far away dots are going to really fly apart, and that's because there's more balloon expanding between them. Here's another picture just to illustrate that same thing. Let's say we're on this top corner dot here, and we measure our distances to these two other dots. The one that's closer to us, it moves away as the space expands, but the one that's further, it moves away even more. So the more space there is between two dots here, the faster they will move away from each other. Okay, and this is why light gets stretched out, because as light from a certain galaxy is making its way to us here on Earth, space is expanding. And because space is expanding, this light wave gets stretched out. And that's what's causing this redshift that we see. It's actually due to space expanding. And it only happens over big, big, big distances where there's enough space so that the cumulative effect of all of this expansion really has an effect that we can observe. So I'm not telling you that right now the space between you and your computer screen is growing. It is, but it's not enough for you to notice. It's so minuscule that in order for you to actually notice when space is expanding, you have to have so much space adding on top of each other, adding, and adding. All of that expansion only becomes noticeable at the distance between galaxies. So whenever so much space that we're talking about the space between here and another galaxy, that's when it becomes noticeable that space is expanding and growing apart. So, um, so that's an important conclusion for us today, that space is expanding. And I want us to also consider one final question today, and that's, what is at the center of the universe? If space is expanding, well, what's in the middle? What's at the center? Um, is Earth in the middle? Since everything's expanding away from us, does that mean we are at the center of the universe? Well, let's just think about this a little bit. And I've got a little illustration for us here, and it gets a little trippy in a second, so try to stay with me here. But let's say that this is present day, okay, and this represents these all these dots represent galaxies. So I'm going to make the false assumption that all the galaxies are laid out nice and evenly here, spaced out perfectly from each other. And let's say that this is our home galaxy. So this little star, this is us. Okay, so as we look out in space, we see all these other galaxies. Now, if we could just like do a little thought experiment here, and let's say that I expanded the space between all of these galaxies, and I'm going to keep us right here in this spot, but I'm going to say that all the space around all these other galaxies everywhere is going to expand and grow. So if there's space, it's going to grow. So I'm going to let the space expand, and I'm going to show you what would happen after space has expanded a little bit. So in the future, this is where it gets a little weird. In the future, after space expands a little bit, you'll notice, okay, we have these other dots right here have moved away a little bit, okay, because there was a little bit of space to expand. But the more space there was between us and the faraway dots, the more expansion there was. And so these dots over here, you can clearly see those are moving away faster. Okay, so we're seeing the farther dots move faster. So you might think that this means we are at the center of the universe because everything's expanding away from us. But what if we did this experiment again, but instead of saying that we were over here, let's say we were actually over here in the universe, just for speculation purposes. How would our view be different if we looked out at space from this perspective? Well, we're going to keep this dot fixed in place this time, and I'm going to let all the space expand again, and I want you to see what's different. Okay, ready? So looking from this perspective, it's actually an identical viewpoint. It's identical because from this perspective, everything still appears to be expanding away from this dot. So no matter which dot you pick, it always looks like everything's expanding away from you. Because if you look, remember it's the space that's expanding, not the galaxies that are moving. And so because the space is expanding, it looks like all these other galaxies are moving away from this spot. So you can pick any spot on here, any dot at all, and it will appear that everything is moving away from it because space is expanding. So to answer the question, well, what's the center of the universe? The answer to the question is we don't know because it looks like no matter where you're at in the universe, it would appear that everything's moving away from you. So there's not really a good answer to that question. It's something that we have been unable to answer using science. So that's something to think about, something to consider. And one final example is a piece of raisin loaf. I like to think this is more chocolate chip loaf, but the thing says raisin. Anyway, as you cook a piece of bread, as you bake it, it will rise and expand. So all the bread will expand away from each other. And if you picked one of these raisins, imagine being a raisin in a raisin loaf. At first, you're all scrunched together in the uncooked dough. But as the dough expands and rises, all your other raisin friends move away from you. Right, and that's kind of how space is working, and us and the galaxies around us. We're all moving away from each other because of the expansion of space. So we will kind of end it there today. Space is expanding. The reason why galaxies appear to be moving away from the Milky Way is not because they're flying through space, but instead the space between the galaxies is expanding. So I want you to answer this question here. So if the universe is expanding now, what does that mean about how the universe used to be? What if we hit rewind on the universe? What does that imply? All right, we'll answer that question next week. I hope you guys have a great weekend. And if you have any questions for me, as always, email me or post on the discussion board. Bye.